Nice to have you with us. Welcome, everyone. So it's 3 after, and welcome to today's webinar on ocean-driven solutions for a sustainable economy and resilient communities. I'm your host today. My name is Daniel Lee. I work at EUMETSAT, and I'm happy to be joining you for this set of really interesting talks and also walkthroughs of some really practical notebooks that I hope will be helpful in your work. So the EU Ocean Data webinar series is focusing on European initiatives as well as data from Copernicus and other places that supports the UN Ocean Decade Goals for sustainable use and protection of the oceans. And in this webinar, we'll be looking at 3 topics, namely Earth observation, in situ observation, as well as modeled marine data. And we're excited to share these with you because we think that, among other things, these 3 topics will support the UN Ocean Decade challenges 3, 4, and 6. So number 3 is to sustainably feed the global population. Number 4 is to develop a sustainable, resilient, and equitable ocean economy. And number 6 is to increase the community resilience to ocean hazards. So 3 really, really big and important challenges that have wide-reaching impacts on people's lives. And that's why this is an exciting thing to be a part of today. So before we get started, there's some housekeeping. As you may have noticed, this webinar is being recorded. So for the people who can't make it, they'll be able to watch, even though they won't be able to participate in real time unless they have a time machine. You're welcome to ask questions, and I see lots of people writing into the chat. That's great. If you have questions that you would like to direct directly towards, or if you have questions that you would like answers to, then please write those into Slido, and you can see that there's a link to the Slido event in the chat. It just makes it a little bit easier for us to monitor what's coming in. And also, if there's a question that somebody else has asked and you think is important, you can upvote it there. And please, when you're writing in questions, say who the question is aimed at. And just to see how well we're getting on with the technology, we'll test that in just a few seconds. We're going to have some inputs in the first part of the webinar in the form of presentations from EUMETSAT, CMEMS, and EMODnet. And that will take us out until 3:15 Central European time. At that point, we'll have a 5-minute coffee break, but you can drink whatever you like. And then at 15:20, we'll get started with notebooks, and that will be more in depth. So again, we're very happy you're here. Exciting topics, contributing to important challenges. And if you have questions, please put them in Slido and say who your question is directed to. And before we jump into the presentations, let's head over to Slido, and I have 3 questions to warm us up and make sure everything's working. And for each question, you get 30 seconds to answer. And some people have already done it. So I'll give just a few more seconds. Awesome. So it looks like we have people from all over the world. And indeed, is that every hemisphere? Yes, it is. Okay, so we're a worldwide community today. Wonderful. Happy to have you all here. Let's go on to the next question, please. So this question is, what is your field of expertise? And I'll give 30 seconds to answer that one. Okay, and again, I see some people writing into the chat. You're welcome to do that, but if you want it to show up on the screen, you need to write it into the Slido link. And I'm reposting the Slido link so it's at the front of the stack. Awesome. Wow. Look at all these disciplines. Well, this is really exciting to see everything that you all are working on. Now, I have one final question, and it's the most difficult question, and that is, what is your favorite marine creature? And I shouldn't need to say this, but I'll say it just to be explicit, it can be an invertebrate, but it can also be a vertebrate. We have some really cool ones. Spine-tailed devil ray. People love octopus. Juvenile harlequin sweet lips. I'm with you there. Somebody put Cthulhu, which is terrifying. Double rebreather tech diver. Basking sharks. Okay. Wonderful. Okay, so what have we learned? We've learned that we're a global community working in a variety of disciplines. Some people have very good tastes in favorite marine creatures. Some people have terrifying tastes, and you're all welcome here. Glad to have you. So moving swiftly along, the first presentation of today is from Professor Nadia Pinadi. She's a full professor of physical oceanography at the University of Bologna, as well as the director of the Decade Collaborative Center for Coastal Resilience, and the author of more papers than I can count over a wide range of topics. So I'm very excited to hear from you, Nadia. And without further ado, the floor is yours.
Thank you very much, Daniel. And I'm trying to share now, the PowerPoint presentation. Hope you can see it. Okay, so thank you very much for inviting me into such an important topic as ocean-driven solutions. And I would put first resilience communities. So we are a Decade Collaborative Center, which was born to help the UN Decade find such solutions together as much as possible, sharing it while we are on the making, so with a strong co-design. And so as you know, this is the situation of the Ocean Decade. It's our Decade Collaborative Center for Coastal Resilience Framework. And we're particularly, and you can see here the sustainable ocean economy and equitable ocean economy, and you see the other challenges. We are devoted to increase community resilience to ocean hazards. Many of them overlap. So in our challenge, we actually use a lot of knowledge that is developed for the other challenges. And the outcome is, at the end, to get a safer ocean for animals and for humans. So we are particularly interested in having a continuous dialogue with stakeholders, coastal stakeholders, where the ocean meets humans is an area that has been not completely investigated because of lack of, let's say, adequate resolution, both in satellite and numerical modeling. Now things are changing, and the UN Decade will be a revealing period. So we have written to start working on this topic, increase community resilience to ocean hazards. We have written a white paper where we try to outline with a group of people, about 20 across the world, what are the major challenges within the challenge of community resilience. And I should acknowledge my co-chair, Srinivasa Kumar Tumala, from the DCC for Indian Ocean region in India, and now actually has moved to Australia, but still part of the team. So our vision white paper fixes some strategic ambition points, establishing robust people-centered systems for risk mitigation and enhanced scientific and institutional frameworks for coastal resilience. So we have the science more based part, but also the socio-economic part as part of our aim. And we have two major outcomes. One is the early warning systems, people-centered, and the other is recognition that we need adaptation planning. So an early warning for the long time scales, in a sense, is something that is newer than the early warning. So we have listed the relevant ocean and coastal hazards we are concerned with. Most of them are covered. Some of them, I would say, more than 30% are uncovered in a way that are really useful for coastal resilience. And so it is a challenge for the UN decade to produce data for the hazards that still we cannot map with observations and modeling. So the components of coastal resilience, we tried to schematize into three parts, which is the risk assessment, the risk reduction, and the institutional governance social transformation has to follow, or maybe in some cases we see already precedes the setting up of infrastructures for risk assessment and risk reduction. I can't go much in detail, but you can read in the paper maybe the details of what we mean for multi-hazard evaluation frameworks. They're all based on data, and particularly to the accessibility of data, because here the point is make data accessible and usable too. So we like to have this snake, marine snake, which is starting from observational evidence, satellite, and in situ. We have to consider in the coastal area a very important data set that is a digital terrain model that considers topography and bathymetry, and then the model data, which go from short-term forecasts to intermediate prediction to projections, and then the new part, sort of speaking, the last 20-year part, which is toolboxes to understand the compound effects, but also to use this information in a way that can be useful for science-based coastal resilience. So here we're talking about cloud computing and and this webinar is already bridging gaps by showing notebooks, working with the right technology, software technology. So I'm almost at the end. We have also tried to frame some implementation pathways, and the key recommendations are really develop open, accessible information systems for risk management using advanced technologies and data sharing frameworks, which is what this webinar, very important webinar series by the Decade Coordination Office for Data Exchange is organizing, and then integrate coastal resilience targets into global sustainable development goals. So we found that is not really something that you can find so easily. You can find partial targets. And then, so at the end of the decade, hopefully we will have more, and then launch a new system that will get requirements from UNESCO IOC member states, finally, and have a virtuous loop, as it happened, for example, for BET offices and meteorology in general, or climate science, where stakeholder needs are considered and studies are grown out of such requirements and reviewed and then implemented. And I think I will be a link in the chat. Yes, there should be a link in the chat to subscribe to our community of practice. We have a pretty large community of practice. Please join us. Thank you.
Thanks very much, Nadia. That's a great overview. And a reminder to everybody who may want to get your questions answered by Nadia, head over to the Slido and ask your questions there and tag them with Nadia's name so that we know when we get to the QA session later on, they're there for her. Okay, so we're doing very well in terms of time. I'm going to now hand over to my colleague, Haley Evers-King. Haley is our lead marine applications expert at EUMETSAT, and she is responsible for our marine user engagement training. She's focused on Copernicus, and specifically it's the Sentinel-3 and Sentinel-6 missions. And she has a broad experience stretching across operations to data validation to product development. Basically, whenever you have a marine science-based question for somebody at EUMETSAT, Haley is a good person to talk to. So I'm excited to hear from you, Haley. Thanks for taking the time to talk to us.
Thanks, Daniel, and thanks for doing such a nice introduction. So I don't have to say too much more about myself and we can get straight into talking to you about the topic at hand today, which is how we can match some of the marine data products that are available from EUMETSAT to the UN Ocean Decade Challenges. For those of you who attended one of our previous webinars, you'll have seen some of these initial slides before. Bit of the context is the same, but then we'll start drilling down into how our particular data products can be relevant for the challenges, the three particular ones that we're looking at in this edition of our webinar series today. But yeah, just to say a little bit about EUMETSAT and marine data, and particularly about the Copernicus Programme, which is where a lot of the sort of majority of my work comes from and where a significant part of our involvement in marine data provision sits at the moment. We operate two of the Copernicus satellites that have a marine mandate. This is Sentinel-3 and Sentinel-6. And I say two satellites, there's actually currently three of them, and soon to be four, and then five. They're part of a multi-satellite mission constellation. These are the two missions that we're in charge of from a marine perspective. And the data from these missions, I would say, really suits applications where the rapid availability of the data is particularly important to you. So if you need data, as soon as we can get it from the satellite and out to you, these are great missions and we're a good place to come and get that data from. It's also the data that's probably at the highest spatial resolution in terms of where you might see downstream data products available from these satellites. We're providing the data basically as the satellite sees it. So if you want to work with the data in its kind of most original form, if you like, the highest spatial resolution we can give you from this particular mission, then you can come to us as well. I would add to this that the synergy applications of these missions are quite good as well, particularly Sentinel-3, which has an ocean color instrument, a sea surface temperature instrument, and an altimetry package of instruments on board, which means, as per this diagram on the right-hand side of this slide, you can look at various different parameters in combination, which I think is really necessary when we come to looking at lots of challenges that face the ocean. It's not usually just a question of biology, it's often also a question of the physics that's going on as well that we need to know in order to address whether it's pollution and how it spreads or impacts on our fisheries and ecosystems. Usually you need a kind of multi-parameter approach. And so this mission with its simultaneous measurements in three different ways is quite a useful one for that. The data from these missions that we operate features very heavily in the downstream level 3 and 4 products from the Copernicus Marine Service, which you'll hear about later. So they take this data and enhance it for other applications. A lot of the core data is coming from the satellites that you see here. Beyond the Copernicus world, we have further data available from our optional and mandatory programs, which broadens kind of the marine relevance of the work we do here at EUMETSAT. So saying a little bit about that, one place you may want to look further is our Ocean Sea Ice Satellite Applications Facility, which is a dedicated center that takes data from our missions, including our meteorological satellites, and derives other parameters and combines data sets together to make them more usable for downstream usage. So in that sense, they're covering things like sea surface winds, sea ice parameters, and sea surface temperature as well. So we've been doing a lot of work recently since the Ocean Decade kicked off to map our data as directly as possible as we can to the challenges. We know that, as was discussed in the previous presentation, that it's kind of a long way from a signal from a satellite down to a piece of decision making that ultimately makes an impact on our marine environment or our sustainable usage of it. And so what we've been trying to do is say, you may never have heard of altimetry, but it's actually quite useful if you're interested in storms. And we've been doing this under the banner of these different challenges, which are nicely formed for us to kind of orientate our data sets towards societal impact. To do this, we've been generating a series of case studies, and these include, in every case, a web article, which is held within our EUMETSAT case study library on our user portal. These are accompanied by a Jupyter notebook, which has a narrative explaining the data, how to access it, and what the use case is, and also conducts a bit of basic analysis and visualization to help bridge that gap between not knowing anything about the data and actually getting it to be useful for something that'll tell you something about one of the challenges. These different case study notebooks are compatible with different cloud platforms, so you can run them on a hosted processing, but we also provide information so that you can run them on your own local computer machines or any other infrastructure that you have access to. We don't limit these case studies just to our data. Usually our data features in each of them, but we also work collaboratively with our colleagues, particularly at the Marine Service, to show where there's multiple data sets relevant for these different applications. We're very open to collaborate on this. So if you're working on a particular topic using some of our data, we'd love to showcase your work in one of these case studies on our website and to share anything more broadly with the community you have to offer. So let's look a bit at the challenges that we're focusing on today. The first challenge that Daniel mentioned earlier in the introduction was challenge 3, which focuses on sustainably feeding the global population. And I think in this sense, the sort of data that we provide can give you a view on sort of the fundamental ocean biology, which is, of course, very linked to the base of the food chain, plankton, linked to fisheries, aquaculture, etc. Also gives us an understanding of environmental variability and change, so the physics, temperature, the currents that drive the impacts on the ocean biology. And it can also be used to give data on what we consider in terms of water quality and safety at sea that are important for these kind of operations. And once we have this data, what we can ultimately use to give to society then is things like appropriate marine spatial planning, so selecting appropriate sites to put aquaculture. We can offer data towards the generation of things like potential fishing zones to help with fisheries management and efficient fishing, and appropriately selecting sites such as for marine protected areas, which can have knock-on effects in maintaining our ecosystems in a more sustainable way. This sort of data can also contribute to cost-effective operational decision support, and I'll show you an example of that in a minute, where it can help businesses to run more effectively and more sustainably. This is particularly the case in this example here, which is one of our case studies, and you'll find the links to these at the end. So for one of our challenge 3 case studies that we've produced, we showed how you can monitor harmful algal blooms using some of this data. This was in a particular area, in this case, where there's a lot of aquaculture, shellfish aquaculture in particular, but also fisheries. And these algal blooms create quite severe impacts, either through the impacts on health and water quality, but also in terms of the environment. They cause these deoxygenation effects that you can see in this example on the right, where there was a massive crayfish walkout, and actually even sharks and larger fish were killed off by this deoxygenation event. The data here can provide warnings and allow for operational responses to this. So aquaculture operators can harvest early. They can choose to move into different modes of feeding and recirculation, depending on what is important in terms of managing the impacts of these blooms on their operations. And the notebook that accompanies this shows you how to access some of this data and process the satellite data to a particular standard to help you detect these blooms. Moving on to challenge 4, which is about developing a sustainable and resilient and equitable ocean economy. Data, I think, in this context can give us long-term baselines of environmental status in particular. So things like understanding what our physics is normally like or how it varies in the ocean, things like our chlorophyll concentrations, the presence of ocean features such as fronts, whether there's a risk of particular heat waves, there's a certain baseline of sediments in the oceans and how this impacts the wider biogeochemistry. And from this, we can then start to plan efficiently our maritime activities, so reducing the amount of, say, energy that's going into shipping, or appropriately siting renewable energy so it's maximum in terms of its efficiency. We can conduct things like trade-off analysis between different uses of the marine environment. It can contribute to compliance efforts, such as for environmental impact assessments. It can be used to assess the efficacy of different policy, whether that's looking at eutrophication, for example, or other related policy indicators. And it can also be used in the context of adaptation planning, so figuring out where might be the most resilient places to provide shelter against the impacts of climate change. For Challenge 5, this is about increasing community resilience to ocean hazards. This is somewhere where I think EUMETSAT has a lot to offer because of our overlap with the weather world, which of course is in large part driven by what happens in the oceans. So data in this context can give us improved current, wind, wave, and ice measurements. And this then goes into model forecasts, which are available from, for example, from our colleagues at the Copernicus Marine Service, as well as long-term records of climate variables such as sea level. Society then gets forecasts, better warnings, as well as better risk assessments, the ability to plan and be resilient to changes in these things, and protected life and property. And there's just a couple of examples here of some of our data in use for these different domains. I won't say too much about Challenge 5 because you're going to get a presentation of the notebook attached to this case study from Ben later in the webinar today. But this is one example where we were looking at how altimetry can be used to assess and monitor the impacts of storms on the ocean and coastal environment. This is very important data feeding into weather forecasts and warning systems, and the notebook will show you how to access this data and follow a storm in near real time. If you want to learn more, there's a whole bunch of links here. You can get a copy of this presentation later to find more information technically about our data, access further training resources, as well as accessing all the case studies and notebooks that I've mentioned here and that you'll see presented later. If there's one thing you take away from this workshop from me today, it's that if you need any help at all, you can contact us at EUMETSAT at ops@eumetsat.int. That is our help desk. And as Daniel said, if it's a marine question, very likely you'll be talking to me. So I'd love to hear from you. And thank you very much. I'll be here to answer your questions later in the webinar.
All right, thanks, Haley. It was a great overview. Again, if you have questions for Haley now, you're welcome to post those into the Slido and tag Haley there so that we know who you're addressing your questions to. And yeah, you also saw how to contact her if it's outside of this webinar. Our next speaker is a marine expert named Marine Delorme, working for CMIMS on capacity development and also heavily involved in WCAO. Marine, ready for you.
Hello, everyone. Can you see my screen?
Yes, I'm seeing it just fine, Marine.
Okay, great. Thank you. So hi, I'm Marine from the Copernicus Marine Service. I'll provide today an overview of the data available for each of the 3 ocean decade challenges we're focusing on in this session. But first, I'll start with a quick overview. Like Haley said, you've probably seen this before if you attended the previous webinar, but just a quick note on what the Copernicus Service, Marine Service does. So we provide a wide variety of data from different sources like in situ observations, satellite data, and models. This data covers different timeframes from historical data stretching back years to real-time information and forecasts for up to 10 days ahead. It also covers 7 regions, including the global ocean. We also develop advanced ocean simulation systems and numerical models using ocean observation data. These models help us describe, analyze, and forecast the ocean's physical conditions, sea ice, and biogeochemical state, whether at the surface or at depth, globally or in specific regions, and in real time or with some delay. The Copernicus Marine Service focuses on 3 aspects of the ocean: the blue ocean, which covers physical data like temperature, salinity, and wave height; the white ocean, focusing on sea ice parameters such as thickness and velocity; and the green ocean, which includes biogeochemical data like pH, turbidity, and phytoplankton levels. So you can see here the wide range of parameters we provide for each color of the ocean. There is a single access point to the Copernicus Marine Service on the web portal marine.copernicus.eu. And with a simple registration on the website, you can access nearly 300 free products. All the data is harmonized through the same NetCDF format. And in the Marine Data Store, which you see on the screen at the moment, you can use filters like variables, areas, or blue markets on the left of the screen to narrow down your product search. We support all sectors of the blue economy. The challenges we're exploring today tie directly into pretty much all of these sectors. And on our website, you'll find detailed overviews of marine variables relevant to each of these sectors, along with the benefits they offer. So now let's take a closer look at the challenges and the data and variables that match with these. The first one is challenge 3, which focuses on sustainably feeding the global population. You can see here some variables that are relevant to topics such as restoring and managing fishing stocks, improving aquaculture, and harvesting sustainable seafood. On the left, you can see a snapshot of a global ocean product showing the hindcast of micronectin content in the MyOcean Pro viewer on the Copernicus Marine Service website. This data is really important when looking at ways to reduce pressure on marine ecosystems or protect key ocean habitats, for example. If you're interested in this data, you can also find it for download in NetCDF format directly on the Copernicus Marine platform. I've added here interesting use case, which links to challenge 3. This is a solution which was developed by some users of the Copernicus Marine platform and data. You can find this use case as well as all the other ones I'll mention today and many more directly on the website as well. So this tool, which is called Perfect, is a web tool designed to help aquaculture managers and policymakers make better decisions by predicting fish growth and disease risk like vibriosis in changing climate. It combines models that estimate key factors such as time to market, food conversion, and disease risk, all based on open source climate data, so it helps support smarter and more sustainable aquaculture practices and policies. The next challenge focuses on developing a sustainable, resilient, and equitable ocean economy. It impacts numerous blue markets that I mentioned earlier, such as ocean energy, tourism, aquaculture, trade and marine navigation, for example. As a result, there are many indicators relevant to the way we manage and share the ocean's limited resources, which you can see at the center of the screen. For example, here, the chlorophyll A forecast product shown on the left could be useful for maritime spatial planning in order to ensure that human activities take place in an efficient, safe, and sustainable way. I'm sharing once again here an interesting use case, which is about challenge 4, which links to challenge 4. It's a tool very useful for assessing the impact of offshore wind farms on ecosystems. It evaluates these impacts, helps identify the best locations for wind farms by analyzing biodiversity and proximity to protected areas. And you can see here on the screen, if you work on similar topics, there's a list of products that were used in this tool and that could be also useful to you. Challenge 6 now focuses on increasing community resilience to ocean hazards. You can see here some key variables that are relevant to topics such as rising sea levels, early warning systems, and the protection of communities and infrastructure through coastal ecosystems such as mangroves or seagrass bed, for example. Here, the seawater temperature forecast product that you see on the left could be useful for tools supporting search and rescue at sea, or for reducing the navigation and tourism pressures on ecosystems during a marine heat waves, for example. And here is the last use case I'll share with you today. So this tool provides a surface current forecast to support search and rescue operations at sea. This operational forecasting system uses Copernicus Marine data, and it includes real-time environmental factors like temperature, salinity, and drift predictions for the Bay of Biscay. This service helps improve planning and response strategies for maritime safety in the Basque Country, benefiting both local authorities and users in the region. There are just some additional resources that I wanted to point out today, which I think could be very useful to deepen your understanding of the ocean. You can check out the ocean monitoring indicators on the Copernicus Marine Service website. They track the vital signs of the ocean, or you can also explore the annual Ocean State Report for a detailed analysis of ocean trends. The last one has been published in 2024, just a few months ago. You can also explore a lot of different use cases, of which I shared 3 today. And these show how Copernicus Marine data is applied across topics we're covering in this webinar series. These examples highlight the practical uses and benefits of ocean data. For each use case, you'll find a list of the specific Copernicus Marine products that were used, and this could be a good basis for you to get an idea of already existing tools and their contribution to a solution. Don't miss the user corner on our website. It's packed with tutorial, help articles, and even e-learning resources like Jupyter notebooks, similar to the one that Ergan will present to you later on. It also has video guides. If you have questions, our support team is ready to assist you via chat or email. There's even a very cute kind of robot helping you with all the articles. So this wraps up my overview of the Copernicus Marine data for today's challenge. Thank you so much for your attention, and I'm happy to answer any question during the Q&A session later.
Maureen, thanks very much. It's a wonderful overview of the data that you have on offer and how that connects with the challenges. Now we're ready to move on to the next presentation from Vicente Fernandez of EMODnet. And again, just a reminder, if you're joining us, check out the Slido. There is a link in the chat. And if you want to ask questions to, for example, Maureen directly, then tag her in your question and we'll get to them during the Q&A session. So Vicente is joining us from EMODnet. He's a very experienced physical oceanographer, and I'm happy to hear from him. He's been working for a few years now as a scientific officer for international global projects. And yeah, Vicente, thank you very much for joining us. The floor is yours. Just checking on my side, Vicente, I'm not getting any audio from you. Aha. No, I see you moving, but still not picking anything up from the microphone. Mhm. Yeah, it's strange. Well, this kind of thing always happens. We'll give a few seconds to figure that out. Yeah. Before we started the session, we did mic check, so at that point, everything was working just fine.
Can you hear me? Sorry.
Now we're hearing you. Yes.
Okay. Sorry. Apologies.
No worries. Technology can be tricky.
Okay. Yeah. So, hello, everybody. Thanks, Daniel, for the introduction. My name is Vicente Fernandez. I work at the EMODnet Secretariat in Belgium as a science officer. And I want to introduce the third component after the satellite and the modeling component, which is the in situ data. And I want to shortly introduce how EMODnet in situ data and data products help to address these three challenges about food and resilient communities. I hope it works if I change the slide. So first, I want to give a brief introduction of what EMODnet is, which is an European Commission operational in situ data service funded by the Directorate General of Maritime Affairs and Fisheries in the European Commission. And it's a network of more than 120 organizations in Europe, organizations and experts working in collecting and aggregating in situ observations in Europe. What EMODnet does is to provide open and free access. Here is the in situ data accessibility that has been highlighted by Nadia at the beginning of fair data in situ for different environmental components, ranging from bathymetry, biology, chemistry, geology, physics, seabed habitats, and also at human activities at sea. In this webinar, we want to stress how the biology and the physics in situ data contributes to the goals and the UN decade challenges we are dealing today. So for the case of the biology, the EMODnet publishes biology data and data products from species across the whole food chain, from plankton to birds and marine mammals. The EMODnet biology database is being constantly evolving, and when new in situ observations and occurrence data is available, they are published in the EMODnet portal. And I want to show here just an example of how the EMODnet biology contributes to the challenge 3 on sustainability feed the global population, alongside with other sources of data in combination with satellite and models. And I show here in this screenshot a product that has created by CIFAS in the UK, which is a model projection of probability of occurrence of habitat for different commercial fisheries. This is projection between 2020 and 2060. So this tool can help policymakers and managers to establish better fisheries locations and better manage the sustainability of the resources of fisheries. I have to say that this kind of product can be created because in situ data from biology it's available in OBIS and GBIF, and also thanks with the collaboration between EMODnet and OBIS and GBIF. You can see on this website more information about biology data products. Going to physics, which is also very relevant for these three challenges. In the EMODnet portal, you can find in situ data in near real time and also in delayed historical mode on ocean physics. We can say that the EMODnet data is based on established marine data infrastructures and European and international programs, for instance. And the EMODnet is this way a single point of access for in situ data. Also, EMODnet is working on capacity building and tools and trainings to advance in open data sharing of in situ data sharing, which is again very relevant for the value chain. The parameters that can be found in the EMODnet physics are mentioned there: temperature, salinity, sea level, and others. And this data comes from a lot of observing platforms that are mentioned there: some moorings, river gauges, gliders, vessels, drifting buoys, etc. Later today, we will see an example of use cases of how this physics, in situ physical data, helps to address these challenges. And in particular, we will see an example of river flow data and sea level from in situ, and helping the coastal resilience challenge in a extreme flooding event. Without entering more technical details, because this will be better described by the presentation of the notebooks in EMODnet, the EMODnet resources on OGC web services, ERDAP, and Jupyter notebooks can be accessed in this website that is also in the link shared in the chat, where you can find all the information on the EMODnet web services to access all this in situ data and data products. And that was my overview, but you will listen more pre-technical details on how to access all this in situ catalog of data that are useful for these ocean challenges in the presentations in the second part. Thank you, and sorry for the technical problems at the beginning.
Thanks, Vicente. Don't worry. We've all been doing virtual meetings for a couple of years, so we know how computers can play tricks on us. Appreciate the contribution. Again, for everybody, take a look at the Slido if you've got questions for Vicente and would like to know more about that fascinating data. Now it's time to get ready for our second session, or for the second section of today's webinar, which will be devoted to looking at notebooks. And that will conclude with the Q&A session and internal conclusions. Now, I promised at the beginning that we would be having a 5-minute comfort break, and I propose that we keep that. We're very, very slightly behind schedule, but that would mean that we would start the notebooks presentation at 3:25 Central European time, giving everybody now 5 minutes to go grab a coffee. So see you in just a few minutes. And yeah, looking forward to coming back here. Okay, and it's 15:25. So welcome back, everybody. We're now starting part 2 of the webinar. Part 2 is focused on practical applications. So we spent the first part looking at data, model data, in situ data, remote sensing data that is useful in addressing these challenges. And in this part of the webinar, we're going to look at some examples of how to work with that data in detail using notebooks. And just a quick reminder, everybody, the session is being recorded, so if you can't attend the whole thing, then you will be able to find the recording later on. And also, if you would like to repost that or promote that on your social media channels, that would be wonderful. Give it a like, give it a share. We appreciate it. And if you're wanting to interact with the speakers in this session, then please head over to the Slido and write your questions, as well as tagging the specific speaker to whom you'd like to direct that question, and we will get to those during the Q&A session. All right, enough from me. Now let's take a look at our first notebook, and that is from Ergan Fouché, who works on tidal modeling and altimetry corrections. So thank you for joining us, Ergan. I'll give the floor over to you.
Thank you very much, Daniel, for the introduction. I'm going to share my screen. Is it okay?
Yep, we're seeing the notebook now.
Yes, great. Okay, so just like Daniel says, I work at Mercator Ocean, and I work with ocean models and satellite observations. And the purpose of this presentation will be to convince you that these data, the ocean models and the satellite observations, the ones that are available on the Copernicus Marine Service, so these are the ones that Marine presented you just before. This data can be very useful to tackle the ocean decade challenges. So we are going to talk about the challenge number 3, which aims to sustainably nourish the global population. And to do so, we're going to talk about upwellings. So upwellings are an ocean phenomenon that occurs in many regions in the world. And this phenomenon is closely linked to fisheries activities. So I'm going to talk to you, to explain to you how this phenomenon is linked with fisheries. Before we start, the material that I'm going to present you has been developed by partners at Noveltis. You can access the Jupyter Notebook on the Copernicus Marine Service website in the user corner, just like Marine presented you. You have e-learning materials here. And if you have a look at Upwelling, you will find the notebook that I'm going to present you. Again, like Marine said, every material on the Copernicus Marine Service comes with videos. So I won't have time to go through all the notebook during this presentation, but you will find a video that explains everything. You can also find this notebook on the resources in the website of the webinar. And I think that's it. So if you want to access the notebook, you download the data. I'm going to run it on the Copernicus Marine Service Jupyter Hub, but you can run it wherever you want. So I uploaded the notebook on the Copernicus Jupyter Hub, and I'm going to run it here. For those of you who are not familiar with Jupyter Notebooks, this is how it looks. So it's basically just like a web page where you have images and text, and also code cells, Python code cells, so that you can run. And I think that's it. So we're going to talk about upwellings. The program of this notebook is that first we have an introduction to explain what upwellings are. Then we're going to talk about the data that we will use to understand this phenomenon. We will see how you can download the data. And then we will do a little study case to see how to visualize an upwelling event. The aim is, again, for you to understand how the ocean physics and the products that you can access from the Copernicus Marine Service can be useful for fisheries activities and more globally to sustainably feed the global population. So let's start with upwellings. So here is a little drawing on how upwellings work. Basically, it works, it happens when the wind blows alongside the coastline. So the wind chases away the surface water so that the water from the bottom ocean rises up to the surface. And this water that comes from the bottom is colder because it comes from the bottom. It also very rich in nutrients. And so when these nutrients reach the surface, the marine wildlife thrives. So you have more phytoplankton, then more zooplankton, and then more fish. And this explains why in regions where upwellings happen, you have a lot of fish and therefore a lot of fishermen. That's it for the physical explanation of the upwelling. Now we're going to see how we can observe this and forecast this thanks to the products. So we are going to study this phenomenon through 4 parameters. We're going to see the wind because this is what generates the upwellings. Again, it chases away the surface water. We're going to study the temperature because the water from the bottom ocean rises up to the surface and it's cold, so we will see it thanks to the temperature. We will see the nitrate that represents the nutrients, again, that comes from the bottom ocean. And we will see the chlorophyll, as the chlorophyll is what represents the phytoplankton that reaches the surface. We are going to study Eastern Atlantic, so Western Africa, because this is a region where upwellings are very strong. We are going to study the period from the 1st of May 2023 to the 15th of May, the first 100 meters, and we will have daily mean products. In the next sections of this notebook, we present all the products in details. I won't read this during this presentation, but you will find plenty of information on the products, on how they have been computed, etc. If you click on the links here, you can access the web page, and you can click on data access, and you will find the IDs, the dataset IDs, to download them. So here we talk about the wind, we talk about the physical model from which we will retrieve the temperature, and then the biogeochemical model from which we will retrieve the chlorophyll and the nitrates. So now let's have a look at how we can download the products directly from the notebook. As I said just before, all the Copernicus products come with an ID that you can copy here. And then thanks to the Copernicus Marine Toolbox, you can download the data directly from the Jupyter notebook. So you have to specify the ID of the dataset, the variables that you want to retrieve, then the spatial extent that you want to get, the start and end date time, and the depth. You specify the output directory, and all the data will be downloaded directly in your repository. So for the sake of this presentation, I have already downloaded all the data, but we can have an example here. For example, we can redo it. It will ask you if you want to download them. So you can check that we are indeed downloading the correct extent, depth, and time. So if you say yes, it will be downloaded, as you can see here. So yeah, in this section, we download all the products that we need on the specified extent, date times, and depths. And now we can start actually visualizing and studying the upwelling on the region and on the dates. First of all, we have to set up the Python environment. So we are using very basic Python libraries. For all of them, you can access the documentation directly from the notebook. You import them, then you load the products. You can have a look at how the product is structured directly again from the notebook. So you can have a look at the depth values, for example, or the units of the temperature here. This is very useful and handy. And so we can start to study the physics, what happens during an upwelling event. So on this first map, we are visualizing the wind map. So for all these days, so every day you have a map of the wind. You can see that the wind is blowing south alongside the Mauritanian coast here. And we can see also that the color refers to the wind intensity, and we can see that the wind is getting more intense around May 7. And because the wind is responsible for a upwelling event, we can assume that from this date, we will likely have an upwelling event. Because the wind is blowing strong, we shall have fish a few days later. So this is what we are going to see. We are selecting in the next cell, we are selecting a point, and we're going to see how the parameters that we have selected, so the wind, the temperature, the nitrate, and the chlorophyll, how they are correlated on this region. So the first time series that we are plotting here is the wind. So we can see that the wind is indeed increasing and then decreasing. And we can see that as a result of the wind increase, the surface temperature is decreasing because, again, the wind has chased away the surface water, and so the cold water from the bottom has reached the surface. The water from the bottom comes with nitrate. So we can see that the surface temperature and the surface nitrate are very correlated. And what's interesting is that a few days after the nitrate supply, there is a chlorophyll bloom, the chlorophyll increase a few days later. And so we can assume that, again, a few days later after the chlorophyll bloom, we will have a fish bloom and that it will be a good time to go fishing. We're now going to study vertical section to see again how the parameters are correlated, not only on the surface, but also throughout the water column. On the next cells, we are plotting a series of figures to display an animation. And the animation is available here. So here we have the depth here and the horizontal section here. We can see on the temperature figure that we have indeed we have the cold water that has reached the surface. We can see it clearly here. We can see as well the nitrate going up to the surface again, and we can see as a result that the chlorophyll is blooming a few days later. The last figure we are plotting is that we're it's called a Hofmüller diagram. So we will be plotting for one point throughout the depths, the temporal evolution of the parameters we're studying. So this is May 1st, this is May 15th, and we can see how it evolves. So we can see that the cold water is going up to the surface up to here, that this cold water comes with nitrates and nutrients, and again that a few days later the chlorophyll is blooming. So as I said, the chlorophyll is the very base of the food chain, and well, the nutrients at the very base of the food chain, and they feed the very small fish that feed then the largest fish. And this is why when an upwelling event happens, we have plenty of fish, and it's a good time to go fishing. On the map here, you can have access to the real-time fishing boats, and you can see that it's indeed a good time to go fishing. Well, it's a place where people like to fish because the marine wildlife thrives here. So that's it for my short presentation. Again, you have a tutorial video that explains all the codes and how you can plot the figures and animations. You also have on this notebook small exercises for you to change the locations we're studying or to change the variables. And if you have any question, you can contact the Copernicus Marine Service support, and we will be very happy to help you. Thank you very much.
Thank you, Erkan. That's a really useful notebook, and appreciate you walking us through it. Folks, if you have questions for Erkan and you would like to engage with her during the Q&A session coming up in just a little bit of time, head over to the Slido and write them in there, also tagging Erkan, and we will get to them after the presentations are over. So looking forward to engaging with you after that. Now I'm going to hand over to our next presentation, which will be given by Ben Loveday. Ben Loveday is one of the numerous physical oceanographers you've been seeing today. He has a lot of experience with remote sensing, numerical models, as well as in situ data platforms, so covering the whole breadth of everything that we've been talking about today. And that's one of the many reasons why I'm excited to hear from you, Ben. And the floor is yours.
Thank you very much, Daniel. Let me just share my screen. I'm going to assume you can all hear me okay. So there we go. So good afternoon, everybody, and thank you for joining us in this session. As Daniel said, my name is Ben. I actually run EUMETSAT's Copernicus Marine Training Service. So if you have any training needs related to our marine data, then please feel free to reach out to discuss anything related to Sentinel-3, Sentinel-6 marine data. I am the person to talk to about training events and resources and support for our data in general. I'm going to start my demonstration actually at the EUMETSAT user portal, which is the place where we actually collect and display all of our case studies, which Haley gave a demonstration of before earlier today. And I'm just going to try and put that link to that platform in chat, where it's going to be a little bit hard for me to do because I can't reach chat, but I'll make sure it makes it through at the end. And if maybe Daniel, the user portal address, you can drop it in chat for me. If you scan down here, you will find a section called case studies. And at the bottom, if you show all, then you will be able to see all the case studies that EUMETSAT episodically write, including those that are relevant for the ocean decade. And if you click marine, you can filter these a bit more easily, and you can see all the case studies that we engage in. And the one we're going to look at today is called Tracking Tropical Cyclone Impacts Using Altimetry. And if I click on this case study, this will give you all the narrative background to the Jupyter Notebook demonstration that I'm going to give you now. And in fact, I'm not going to go through this because I'm going to show you how to generate some of these animations in the next kind of 50 minutes or so. But towards the end, there is a link that will take you to the Ocean Case Studies repository, which is where we store all the code related to these case studies. If I step back a little bit to this link called EUMETLab, you will find all EUMETSAT training content for all of our sensors, all of our applications and thematics stored within this, this Git repository project. And if I look into oceans and ocean training, you can find everything we do related to individual sensors and everything we do related to applications as well. And I'm going to work in the ocean case studies application or repository here. And all the information you need to set up and launch this repository in any platform really you wish. I'm going to work on my local system, but it's tuned to work on the Copernicus Wekio system. It will work on the Destiny Insular Code platform, and it should still work on Binder as well. And then you can basically spin this up on any of those platforms with full installation instructions provided all the way down here for wherever you're setting it up from the ground up. So you should be able to be self-sufficient to run this code demonstration in your own system, wherever that may be, local or otherwise. Now I'm going to quickly now switch over to my own instance of JupyterLab. This is running on my own system. So I've cloned the code, I've got it all set up and ready, and in each one of our repositories you will find an index file. This notebook gives you guidance around everything that's included in this repository, including all the case studies that we've authored as part of the UN Ocean Decade series, as well as a host of other marine applications and data acquisition examples. And the one we're going to work on is from Challenge 6. So Challenge 6 is, as you've come to already, increasing community resilience to ocean hazards. And if I click on this one to open it, now we are at our notebook proper. We can close down everything else. I don't need it for now. I'm just going to make my view a little bit clearer so we can have a little bit more space to work. And here we are ready to work with our notebook. So the point of this Jupyter Notebook really is to look at a historical storm track and then to look at some contextual information derived from the Copernicus altimetry sensors on significant wave height to look at what effects that storm has had on the surface of the ocean. Now, Ergan has already given a great example of how to run through a notebook, so I don't need to dwell too much on the kind of construction of how a notebook works. But suffice to say, all of this prettiness is just narrative to decorate around the notebook, to give you contextual information, descriptions, and links to other resources. And anything that's in gray here is actual code itself, and will always have these little square brackets next to it with a number inside. Or without a number inside. If it does have a number, it means the code has already been run. If it doesn't have a number, it means the code has not yet been run. And we don't want it to be run at the moment. So I'm going to go to the top, this kernel menu item, and clear the output from all the cells. And now our code is completely blank, hasn't been run yet, and we're free to kind of step through and see some of the analysis that we want to perform. And the job we want to do really is as follows. We're going to go away. We're going to go fetch a cyclone track from 2023 in the default case for Cyclone Freddy. We're going to plot the track of that cyclone, have a little look at the specifics of that cyclone, and then we're going to go and get all the altimetry data and the significant wave height associated with those altimetry tracks to look at what the effect on the sea surface roughness and the significant wave height was as that storm passed by. So we're going to look at two primary data sets, and they are the level 2 altimetry tracks from Sentinel-3 and from Poseidon-4 aboard Sentinel-6. So these are the two primary altimeters that we have in operation at the moment. As Haley alluded to, there is currently one Sentinel-6 altimeter flying. There will be two by the end of the year. And there are two Sentinel-3 altimeters currently flying on board Sentinel-3A and Sentinel-3B. So let's have a little look at our code example. So every time you see me in one of these boxes here, I'm just going to hit Shift and Enter, and it's going to run this code. So I'm going to import, first of all of the dependencies that we need to run this example. And for each one of these cells, there's a description of what I'm doing in each case, but I'm not going to dwell on it too much because we have some limited time available here. And what we're going to do is we're going to say we want to look at Storm Freddy in the year 2023. Now, we are looking in a data set that contains over 100 storms, so you should feel free to adapt this cell to look at any storm that is of particular interest to you. This notebook is configured to look at a few different examples, as I will come to in a minute. But for now, let's just look at Freddy itself. And then we're going to say, do we want to download the altimetry data associated with this storm itself? Now, in my case, the altimetry data at level 2 is rather large, and there's quite a lot of it that spans the scope of this storm, which is in fact the entire Indian Ocean. I've already pre-downloaded the data, so I'm going to say false. But by default, if you get the notebook, this will say true, and it will go and get the data that you need to run this analysis. So I already have mine, so false, no problem. I'm all set up to go. You have the option to include some bathymetry data sets if you have them from the GEBCO web portal. I'm not going to include those, but you can if you so wish. And we're also going to take in some data from the EUMETView web map service system, which is our viewing system for a significant amount of our data. And we're going to look at the RGB air mass, which gives us a very fast updating geo-ring view of storm and cyclogenesis across the globe. So we're going to pipe that in to create an animation and use that as the background to plot our altimetry over the top of. Now, these are just some default parameters that I'm not going to engage with too much, but can be updated as you wish. And here is where we have the default or the kind of canned example set up for the analysis. And as you can see, I'm going to run with the storm Freddy in this case. It's already set up to run with Nanmadol, Hinamnor, Fiona, Ian, Franklin, Lee, a significant number of storms over the major ones over the past 2 years. But you should feel free to update this for whatever storm example is most relevant to you. Okay, so we're not going to include the bathymetry in this case, so this doesn't matter. This is going to skip because we don't have this file set. And then we get on to kind of the main part of the analysis, or the main part of the data gathering for this notebook. So the first thing we're going to do is we're going to download the IB-Trax Hurricane Data Record from NCEI, the National Center for Environmental Information in the US. They provide this IB-Trax record, I think updated on a daily or twice daily basis, which has a list of all of the storms that are, in my case, happened in the last 3 years. That's the file that I'm choosing to get. And this has the latitude, longitude, intensities, and a whole raft of other variables of a significant number of storms globally in the past 3 years in this case. You can look further back should you wish. So now we have this data, we can have a little look and see what we've got. 321 storms were recorded within this time. So we can see, okay, fair enough, there's quite a lot of information there. Not all of it is relevant to us. So we're just going to profile this and pull out the storm of interest for us. So in the next cell, all we do is we provide the name of the storm we want and the year. And now we've only got the stuff relevant to Cyclone Freddy in 2023. We're just going to do a little bit of data curation to pull out some empty parts of the cells. And now we can actually plot the track of this storm. So this is what Freddy did between the 6th of February and the 14th of March. Basically, it started over here in the far east of the Indian Ocean, and then it moved steadily across the Indian Ocean, eventually crossing Madagascar and into the Mozambique Channel over the course of about 2 months or so, or 6 weeks. And during this time, we can see here the time base on the bottom of here, Freddie started to gain some power as it moved over to the warmer part of the Indian Ocean. It started to gain in size as well, then started to kind of like continue to intensify. The black curve is the intensification measured against the left-hand side here, the intensity of the winds in kilometers per hour, before hitting the coast of Madagascar, dissipating, and then starting to recharge a bit once it entered the warm Mozambique Channel. So now we know that Freddie was a relatively strong storm, clocking winds around 250 kilometers an hour, was relatively large as well, its major extent. And I've plotted the outside closed isobar, so it's about 450 kilometers in kind of rough size about where its effects may have been felt. And so, okay, we know what where Storm Freddie tracked and what the wind effects were, but what happened actually to the surface of the ocean as Freddie passed by? And for that, we're going to take what we know about Storm Freddie's track, how far it traveled and over what time period. And we're going to use that to search in the EUMETSAT data store for all of the altimetry products that correspond to that time and space window. Now, the EUMETSAT data store is where we release, should be your major access point really for all Copernicus Marine data from Sentinel-3 from level 2 and Sentinel-6 from level 2 and level 1B. And we regularly reprocess this data, so it's basically the authoritative platform in order to get the highest quality data for all of our satellites, all of our altimetry products. In order to access this data, you will need to have an authentication on our Earth observation portal. There's full instructions on how to get this at the top of our page. And we're going to go away and say, okay, let's look to see what collections of altimetry we have. And you can see we actually have quite a lot of altimetry data that's available in different forms. But the one we're interested in is the level 2 altimetry from the latest reprocessing, which is this baseline collection 05. And the collection ID for this is provided here, this 834. So let's go away and say, okay, based on our search parameters, how many products are available? And there are 449. Individually, they are not that big, but in aggregate, they are relatively large. That's why we're not going to go through the through downloading them all at this stage. So we'll skip the download for now. If download was true, this cell would start. And exactly the same for Sentinel-6. There would be 217 relevant products for Sentinel-6 as well. So in aggregate, we've got somewhere around 670 products that would be kind of in scope for this analysis, which is quite a lot. Okay, so we've isolated where our altimetry products are, and if we'd chosen to download them, we could do so. I have already done that. Now we're just going to pipe in our base layer, which is from the EUMETView system, which is going to give kind of our contextual information on our storm genesis. And put this all together, we're just going to pull together all of the information from all of our wave products for significant wave height is in the altimetry level 2 products. Okay, and then we're going to go through every single time step, every single day, and we're going to draw the altimetry tracks and the significant wave height over the top of the base layer taken from EUMETView, so we can see on a daily basis the update of how this storm is progressing and what significant wave height data we've got that corresponds to that. Now I'm going to set this running. This takes some time, so I'm just going to show you what the individual panels look like. And it's going to go through, and every 5 ones of these panels, or every 5 days, for example, it's going to output one of these panels. And the panels broadly look like this. So here we can see this is Cyclone Freddie as it begins its journey through past the north of Australia, south of Indonesia. And the size of the storm corresponds to the radius kind of impact, or the size of the ring here, and the color corresponds to the sustained wind speed. And all of these tracks are the altimetry tracks that show the significant wave height, in some cases associated with this storm. And you can see here, Freddie is starting to cause major significant wave heights of over 7 meters in this case. And as we put all these points together, and the notebook will make this exact animation, we can see how Freddie causes this significant wave height pulse and the movement of these waves across the Indian Ocean and then into the Mozambique Channel as it flows across the Indian Ocean. And we can see here, once it moves on to land, it starts to dissipate. There are some interesting things to consider here. Number one is that Freddy is not the only storm that is in scope here. We're only looking at Freddy, but it's quite clear that there are other large significant wave heights occurring at the southern part of the extent of this map associated with other storms. But this quick analysis can give us an idea of what effect Freddy is actually having on the local sea surface, and to some extent tell us a bit where those waves might propagate to. On the point of propagation, if you look back at the tropical tracking tropical cyclone impacts case study, you will note that there is a second level of analysis where we've used the wave products from the Copernicus Marine Service to look at what impacts the cyclones may have had on the forecast of these waves and where they may have dissipated to. So there's some linkage here between the products produced by EUMETSAT and those contained within the Copernicus Marine Service as well. So just popping down to the end of this analysis, how far have we got? Pretty far. We're about 3/4 of the way through, but that doesn't matter. I don't need to run these last two cells because they only plot the animation that I've shown you already anyway. This is just one example of how we use our data in one specific context. At the bottom of all of our notebooks, you'll find information for how you reach out to us for more info on how you can use this material, which you can do so in any context, how you can adapt it, or any questions about our data use at all, then please reach out. If you have any ideas for new case studies you'd like to pursue and collaborate on, we'd love to hear from you. Best of luck playing with the tools we've got. Any questions, please come to us and ask. Thank you very much.
And thanks very much to you, Ben. This has been really interesting. I was a little bit worried. I have a friend named Freddy, so watching that cyclone go towards Mozambique maybe make a screenshot to send to him. And thanks for sharing.
Yes, it's 2023, but we can do this near real time as well.
Okay, yeah, good to know. All right, so folks, if you have questions for Ben, Slido is your friend. Go to Slido, write them into there, flag Ben, and he'll be happy to engage with you after the notebook session. We just posted the link, and you can also see there are some other resources that we put into the chat if you're interested in finding out where our notebooks are, how to get to the user portal, et cetera, et cetera. It's all there. So the next presentation that we will be hearing is from Salvador Fernandez. And Salvador is a science officer at VLIZ, as well as a data manager and a data products developer, so a person with many, many hats. Very active in the world of R, which is one of the environments that is, of course, interesting. We have been looking at Python stuff so far, so I'm looking forward to hearing from you, Salvador.
Can you hear me, guys? Yes, I'm here. Can you hear me?
Yes, hearing you just fine. So yeah, Salvador, the floor is yours.
Yes, so I will just share my screen really quick. And yes. All right, can you see my screen? Remember, you will see GitHub at the moment.
Yes, we're seeing GitHub now.
Okay, perfect. So yeah, welcome everyone. Yeah, so as Vicente was saying before, we are going to be showing how to access in situ data of EMODnet. So in this case, we're going to look at EMODnet biology. That's going to be my part. Then later, my colleague Pedro, he will show EMODnet physics. I think this link will be shared. I prepared these notebooks. They are in GitHub. They can be launched with Binder. And also, if you use normally Docker, you can also replicate the same environment, run it there. And if not, you can just do it directly on your computer. Hopefully it works, because you need to take into account that most of the packages I'm going to be showing, these are things that are under development. So these things change over time, allow for some room for changes as the API of EMODnet evolves. So first, I'm going to show two different notebooks. I hope they're short, because we have two different parts in EMODnet biology. We have the occurrence data, which if you're not familiar with this term, is as Darwin Core defines, is the existence of an organism or a group of organisms that are taxonomically homogeneous. So let's say like it's the same species or the same genus, gender, or the same family, etc., in a particular place and time. So these data are published normally through web feature services. I want to call it WFS. And yeah, what we have been developed the last years is an R package called EMODnet WFS. that allows you to access not only the data from EMODnet biology, but data from all the EMODnet thematic lots. So I want to show here is how to use this package to read the WFS services and retrieve the data on your computer and do whatever you want, of course. I'm not going to read everything. Will have the link. You can go through it, and I will just go quickly through the code, show you the main points. There's a bunch of libraries here that I'm going to be using because they're necessary to show different things, but the important one is EMODnet WFS. This package offers you, first of all, a simple function, EMODnet WFS, that tells you all the services that are available in EMODnet. This also changes over time. We try to keep them updated. And it also gives you the URL to it, and also it tells you what thematic lot it is. What we're going to be looking at the moment is as this one in particular. So biology has 2 different services for different types of data. And we're going to be looking at biology occurrence data. We use that this term that we can pass to the first function, that is to create a client, to create a WFS client that you later can query data, concatenate information, and see more things. So you first pass it to the function, and then you can get extra information about it. And for example, what I'm doing here is just selecting a few columns to see more what is in there in this service. There is a lot of information that not all of is relevant, so we need to pay attention to the abstracts of them, see what we're looking for. In particular, here I will show a bit more in detail here. There are 3 data formats available in EMODnet biology. It's the same data, just it gives you different level of complexity, so the different columns and so on. So in case that you need more or less information. Here I'm just querying the data and filtering on the 3 different layers that are of use for us, which are the basic occurrence data, the full occurrence data, and the full occurrence data and parameters. As I say, that what it changes is the number of columns you receive. And if you need more information, you can always go to the EMODnet documentation website, and you will find more information about it. What I'm going to be doing here, before I show you, it's we need to make a query of this data. It uses a specific type of technology that is part of not only WFS, but it's part of GeoServer. That is the technology that we are using. So it's a bit complex to write these queries. And the easiest way that I propose for you guys is to use the Eurobis.load toolbox. Eurobis is the European node of OBIS. And what this toolbox does is just create you a download URL with the query that you need, that we can later pass to the package. In here, this is how it looks like. I already have selected the data. So in this case, we're going to be looking at the marine mammals in the Arbolan Sea. Already selected the Arbolan Sea, which is of interest here is that because it is powered by the World's Register of Marine Species, is that we can select not only a specific species, but we can also look at other taxonomical groups that are not taxonomically sampled. Like we can look at all mammals or also phytoplankton, groups that are functional groups that are of interest to us. In this case, I'm going to select mammals. You go to this screen. You can select the type of data you want. For example, let's say occurrence data, full occurrence data. And here you can get the URL web service. You can copy it, come back to the place where you're developing, and here is how it will look like. Bunch of information that is not important at the moment. The only important part is this section here. This is the query that we need to use to retrieve the data that we're looking for, and you can directly pass this to the next function. But I put here like a helper that just extracts you that part. So we can use this function, EMODnet get layers. So this is to retrieve a specific layer. You pass the client that we created before. You say what layer you're looking for. And this is going to be all the information that is available. You pass the query on this parameter and then view params. Then there are different things. You can also limit the number of rows that you're retrieving and other details that you can find in the documentation. Once we do this, we get about 4,500 occurrences of marine mammals. And this comes in the form of a simple feature object that is like the way that R deals with the vector data. And here you have all the information you can find here. As I say, it's a good amount of columns. And but what we're looking for here at the moment is just to retrieve this data and do a couple of things with it. Once we have it, because it's vector data already, we can do any kind of vector activities with it. For example, we can make a plot. As you can see, this has been selected to only the Alboran Sea and the marine mammals. That is what we're looking for. And of course, we can save this. We can save it as vector data. So just you can just use the SF package, which STGride, in which like you just pass the object you created, you pass a directory, and then it's saved there. Or if you prefer to only save the data as a CSV, you can also just delete the geometry with ST-drop geometry and save it as a CSV. As you can see here, this is just to show that things are saved where it's supposed to be. Well, this is how to access in situ data for biological occurrences, but as Vicente was mentioning before, we also have data products. Data products, they are in another system, so we need to use different packages for that. And that's going to be my second notebook. To access data, the data products of human biology, these data products are uploaded to ERDAP. Maybe you're not familiar, you can access it also in this direction. And this is the ERDAP server of the whole EMODnet. And here is also included all the products of human biology with a lot of other products of other EMODnet lots. So what we do here is we need to pass this specific URL. We're using this package, ERDAP. That is the package that lives with the ERDAP servers in R. Here we just need to pass the URL, and we search for anything we're looking for. In this case, we're looking for things that are from EMODnet biology. We just pass that, and then we get here a list of all the products of EMODnet biology. Here we only get the title plus the dataset ID. This is important because we will pass it later to download the product we are looking for. And what we can do to get more information is use this other function that is ED datasets, in which you pass the URL and then you get the list of all the products with a larger number of columns, as you can see here. Here I'm selecting only the title and the summary, so you can immediately see more information about the product without needing to leave your R session. For example, this product here is the one that Vicente was showing before in his presentation. And the one I'm going to be using for this exercise is this one, probability of occurrence, 3D maps, it's called. It was made by the ASTI in the Basque Country in North Spain. And this is a product of 40 species of fishes, commercial fishes, at different depths. So we need to use this ID here that we can pass to the info function of ERDAP, and then it will give you more information about this product. So, for example, it will tell you these projects are natively created as netcdf files. So netcdf files are multidimensional files, so it allows to save data that has different dimensions, like normally depth, latitude, longitude. And in this case, it's important for biology. We also need the taxonomical dimension, in which, like, in the same file, we save also a different species. In this case, we have 40 species, so we need to save them in the same file. What we have here, we call it AFID. That is the identifier in the World Register of Marine Species. So you could use this ID, go to the World Register of Marine Species, and you will retrieve more information. What we do here, we're going to print more information about the dataset just to see what it has before we try to download anything, because these products are really heavy, so it's really difficult to download everything at once. So it's better to just get the part that you need. And you can see more information here. You have a lot of information about metadata, who created, emails, the extension, and things like that. And also information about each of the dimensions. As you can see here, the taxonomical dimension was mentioned, the AFID, but also depth, latitude, longitude, etc. And the variable that we're looking for in this case is the probability of occurrence, so the probability of occurrence of any of these fish species. What we can do here, it's we need to pass the taxon as an FID, as an identifier. So we can use another R package that we developed, that is the worms R package. And in here, we can use the function WM records name. pass a name of a species. In this case, I'm using the anchovy, Grallus incrasicolus. We pass this, and then we get a number of information from this species that is retrieved directly from worms. What you can see here, there are 3 different names for the same species, and the one that is accepted is this one. So we are going to take this ID to pass it to our query. Now, to create this query, we need to take into account, in this case, 4 different dimensions. We are going to focus again in the Alboran Sea, in the Strait of Gibraltar. And we also know that this species is epipelagic, so it ranges from the surface to 200 meters. So we're going to query only these different depths. So yeah, we use the spatial extension for this area. We use the different depths at which we know that the species lives. And we pass also the FID. In this case, this is a technical limitation. We need to pass it as a range, but this is basically repeating the same ID I mentioned before. Once we have this, we get it. Well, it's happening here is you actually are downloading a subset of this data, and you are downloading it as netcdf, in a temporal directory. So once we do this, we can immediately look at the data. It will show us as a table, and it will give you more information as like what it is and the dimension that it has, etc. As I said, this is saved. This is already saved in your computer, but you can also choose where in case that you need to download to your own project. You do this using a specific argument here. That is the argument store. So to download the data, you need to use the grid-up function, in which you pass you can pass, for example, the information object we gave before, but you can also pass directly just the identifier of the dataset. And here in the store argument, you specify where you're going to save it. In this case, I'm creating a temporal directory, and I'm saving it there. And the same, you need to put here the query that you're doing. So different FID, depth, latitude, longitude. You can also do this as a CSV instead of netcdf if you prefer this format. And here I'm just showing that I'm reading this data, and at the same time it's being downloaded to the directories that I created that I wanted them. So it's here, we have one file as netcdf, one as CSV. And the same, when we have this, we can do different types of studies on it. In this case, I thought it would be interesting to see what is the difference in the mean probability versus depth. So we did here some data wrangling with the plier, and then I made a plot, and we can see here how the probability is higher. The highest probability is at 175 meters, and it just goes up with depth. So the more deep, the most probable it is normally to find it, according to this product. Yeah, as we have this, we can also make a map. So just we convert the data. Yeah, we just filter on one single depth, because otherwise we couldn't visualize this because it has multiple dimensions, right? So we need to have only one slice of data. And yeah, we can put it in a ggplot. We make a map, and we see how is the distribution of this species according to this plot. Voila, this is my presentation. You can find all the links here, and if you have any questions, drop them in the slide.
Okay, thanks very much, Salvador. That was really useful also to see another language that we can work with and all the packages that you've developed there. So thanks for sharing that with us. That brings us to the conclusion of the notebooks presentation. So I don't think that we can in this platform, but let's all give them, rather than giving a Teams clap hands emoji for everybody, let's give mental clap hands for all the presenters, both those presenting the data as well as those presenting the notebooks. All right, I just clapped a lot in my mind. Excuse me, I'd gotten my wires crossed. So we're still clapping for everybody, but we have one more presentation, and that is from Pietro Villino. Pietro, apologies.
No problem.
I am, however, excited to hear about your work, so I'll hand the floor straight over to you.
Thank you very much. Yeah, I know it's already been a lot to follow, so we are all a little bit tired. I'll share my screen. Okay. Can you all see it?
It's coming through fine on my end, Pietro.
Okay, nice. I'll present a notebook showing how to access EMODnet physics data. And I choose as an example to show, mainly visualize the data by showing from two parameters the catastrophic climatic event that took place in Valencia in October 2024. And this is a notebook as the ones that we have seen before. I chose to have it hosted on Google Colab, which is the same kind of file as the ones that have been shown before. In this case, Google provides us with an environment with already some basic libraries installed, but the logic is the same. There are test cells and code cells which have to be executed. The first step is for this example is I'm accessing the data from this access point, and we can see here all the data has been grouped into time series, which is this part, and profile for a lot of different variables. You can see here what I mean. In this example, we said we have chosen the river flow rate to show the impact from that side of the event. And by accessing this, we'll get to this page. And here it's really simple to construct queries that can be used, and I will show you in a second, can be used by Python code. Here I have already chosen one of the station that I will use. Here with the sliders it's possible to select a filter, and by checking or unchecking here, we can select which variables we want to download. Last step here, it is possible to choose a different format. Now I'll show you just as an example the HTML table, so that can be seen in the browser, the result. And okay, it might take some time because we are downloading now 2 months of data. But as you can see, there are all the variables we have chosen from the desired period of time. Okay, let's get back to the Colab. As first step, here I perform the imports of the libraries that will be used. And in this case, I have chosen libraries that don't need to be installed inside the Colab. Of course, if somebody wants to download the notebook file and run it outside the Colab environment, so these will have to be installed. Okay, here are the two platforms I have chosen to show the river flow data. And as in the example, from there that I was showing before, 2 months of time. So we'll first initialize a map focused on the Valencia coordinates, and initialize also a marker cluster because we want to pinpoint on the map the position of the stations that we have chosen. Here is the URL that will be passed, and okay, with a single line, then we can import using pandas, which is a very useful library for data elaboration and analysis. We can download the file. You see here I've chosen CSV in this case, and already import it into what is the base template data structure of pandas, which is a data frame, sort of like a table. I will show you in a moment. With these lines, we finally insert the markers inside the map. And you see the two stations that I have chosen now are near Valencia. Okay, here is where we actually download the variables that we need for the later plotting, the limit of time. And as before, just with this line, in a single step, we can download and load the data inside the pandas data frame. You can see here, in this case, it's 118 lines. And from the timestamp, we can see it's daily data. Here is the variable river flow rate expressed in cubic meters on seconds. Okay, with this code cell now will plot the data that we received. There is a little bit of data cleaning and elaboration here, mainly on the data types. And then here, when we made a request with both platforms, 2 different stations. With this line, we split the data frame into 2 data frames based on platform code, which is the station name. And then we, by iterating through these 2 data frames, we can plot the data. And I chose to add with these 3 lines, getting the index where the river flow rate as the maximum value, and then to insert here in the label the time in which the peak was reached. So you can see the extreme peak that happened in the 29th of October. For both of the stations, we see clearly a peak. In modern physics, we also had river flow data from another station, which was much closer to Valencia. Using the same logic, I will show you now the position. But as it may be clear, we'll now see that the data with the same lines has been imported into a pandas data frame. In this case, we can see also from just mainly by looking at the numbers, some anomalies. For example, the data stops on the 28th of October, gives us not a number value on the 12th of November, and then has some what appears to be wrong readings, because 3 readings with the same values in 3 days are a bit too suspicious. Not impossible, but suspicious. Anyway, we'll try to plot this data that we received. And you can see also visually, it's pretty clear that something happened to this station during that period of time. And this was regarding the first parameter I was talking about, the river flow rate. Now I'll briefly repeat the same logic with very similar code for the sea level. So first we look at the point of view from the rivers, and now from the sea. The 2 stations I've chosen are this one, and the period of time is the same. With the same logic, I'll show you the position, and in this case we have 2 stations which are in the port of Valencia. Okay, I'm sure you are already all getting used to it, but with passing the URL to AirDAP, with this line we import it into the pandas data frame. And now I want to execute the cell codes. In this case, it will take a bit longer, because if you remember, in the cases before, it was daily data. In this case, we have an observation each minute. So for the same 2 months period, now it's about more than 160,000 rows. Can be minutes to download, a couple of minutes maybe. Okay, now we'll do the same data cleaning and show in the plot the sea level data, in this case expressed in meters. Also in this case, the peak was reached on the day of the flooding, main day of the flooding. It's not significant as on the river, because of course the sea is subjected to many different forces, but all the same, in these 2 months selected for the brief analysis, we have the peak. And I guess for me, that's all.
All right, Pietro, thanks very much. And now it's actually happened that we've reached the end of the notebook session. So thanks to all of our presenters. I will clap on everybody's behalf. Thanks also to those who are presenting in section 1 about what data addresses what challenges. So now we are going to go over to the Q&A session. If you have not submitted questions yet in Slido, then I encourage you to do so now to make use of this chance to talk with the presenters. So the way that I would do this is, as soon as we've got this up on screen and visible, it's a little bit small at the moment. I'll just read out the question and the presenter that it's for. And if you're the person answering that question, then please just unmute and say anything that you'd like to share with the person who was asking the question, and then we'll move on to the next one. So the first question is straightforward. Will we provide a certification, a certificate of participation? And if you write an email to support@EUData for oceandecade.eu after the webinar, we'll be happy to provide that certification to you. Then next question, how is research collaboration possible? And I believe this one is directed towards Nadia. Nadia, is there anything you'd like to share with this person? I'm not sure if we still have Nadia in the room, actually. Okay, well then I would open the floor to any of the presenters. All of you are engaged in research or have been engaged in research of various types. It's a fairly broad question. What words of wisdom would you share with regards to enabling research collaboration?
Maybe I can start and say something that there's quite a significant number of related kind of funding calls that come out, particularly around things not necessarily directly on the UN Ocean Decade, although I'd stand to be corrected by anybody who's more involved in the program if there are associated ones. But certainly from the EU perspective, a lot of the links between the Copernicus program and things like the Horizon Europe and framework funding programs are geared in the direction of supporting research collaboration, particularly around impactful topics such as these. So trying to facilitate people from different backgrounds. We saw all your wonderful different areas of expertise earlier to work together on collaborative things, especially if they're leveraging the use of this data. So definitely check out some of those. I think maybe Marine, if she's still here, can say a little bit about the research opportunities available through the Marine Service. I know they have specific funding calls as well as things like that. Otherwise, using the opportunities here to reach out and network with some of the people one-on-one to speak about who they know in the community. We're always happy to hear those kind of questions. If you're looking for an expert in a particular topic, we'd always try and connect you.
Anything else to add? Maureen, anything from your side? Okay. Well, thanks, Haley. That's an encouraging answer. Next question is there any ongoing data gathering activities in the area of recreational craft/boating? And I see, Ben, you provided an answer here. Would you like to elaborate that for the questioner?
Yeah, I'd happily do so. I'd preface my response to say I've worked a little bit on tracking of illegal fishing, which tends to be larger vessels, but vessels that are always in operation, even if not necessarily honestly doing so. Without some sort of secondary information stream like VMS or AIS, which in the case of a vessel that had been abandoned may not be operating, then you'd rely on radar data primarily from something like Sentinel-1 or ISI or another commercial operator. And whilst this is possible, you are then relying on the vessel itself having a fairly large radar cross-section, and also that the revisit and coverage of that sensor will be able to sample with the spatial temporal frequency you'd need to respond. The last part of that question would be whose responsibility is it to respond, which if you're not in an EEZ is never particularly clear legally. So it's a very difficult issue to tackle both technologically and kind of like in terms of a framework for someone to do anything about it. It's a salient issue. It's just a hard one to tackle. I don't know of any active activities with regards to this at a global or even a regional scale.
All right, thanks, Ben. Anything else from the other panelists you'd like to add? Okay, well then I'll move on to the next question, and that is directed towards you, Haley, I believe. Which software do we use for monitoring ocean storms?
Yeah, I think I put a rough answer to this already in the Slido, but I was basically saying that if you want to look at, well, I was pointing towards Ben's presentation, so you can see how you can use Python to gather the data, to visualize it, and do a little bit of analysis of it. This is something we use. But if you're more broadly interested in data that's relevant to ocean storms beyond the altimetry, another thing you might want to check out is our EUMETView service, which offers more of the weather perspective of storms. And you can see data readily visualized there in near real time that's relevant for storms as well. Beyond that, I would highly recommend checking out some of the short courses and other training courses that we offer at EUMETSAT. We offer quite a bit of support for marine forecasting, and there you'd be introduced to other types of data and particularly different types of software that's beyond the scope of kind of the oceanography side of the world that I come from. But do check those out. If you visit training.eumetsat.in, you'll find a lot of our courses there.
Awesome, thanks very much. And another one for you, Haley, asking about our level 2 data for optical color for the Olchi.
Yes, we certainly do provide this data. And again, I put some links in the Slido to some different places you can find it. We have a guide to this data on our user portal. It contains the information about the products that have the ocean color data, as well as the derived geophysical variables you might be interested, chlorophyll, sediments, etc. There's also some links to where you can find the data, for example, in our data store. And I think Ben also put some links in the Slido that show where you can get some additional notebooks to help you work with this data, which have a whole Olchi repository, which can introduce you to accessing this data, its formats, and working with it for a variety of different applications.
Great, thanks very much. Next question is to Vicente. Do the in situ data you provide include inorganic parameters? And you've got some nice parameters listed there. Vicente, I think we're running up against the same mic issue we were having earlier. Sorry about that.
Well, maybe I can answer in between if
Yeah, go ahead.
Okay, yeah. I already answered in the Slido, and yes, thanks for the question. And yes, EMODnet in situ parameters are also for chemical parameters. So all the observing platforms that provide chemical parameters are the one, the inorganic, phosphorus, nitrogen, etc., can be accessed through the EMODnet portal. I gave already the link in Slido.
Awesome, thank you very much. Okay, then the next question is a fairly broad one, and I'll pose this to all of our speakers. What are the major data gaps in ocean monitoring? Go.
Yeah, if I may say, at least in the perspective of EMODnet biology, there's a clear data gap. Like there is data of the North Europe, and there's no data in the Mediterranean, and there's no much data in the Black Sea either. So yeah, those I would say those are the major data gaps. As you will see in my presentation, also like I was showing, the difference. It's really clear the difference in the strategy router on all the Mediterranean. You can see how all the European countries in the Mediterranean they have data, but in North Africa it's the same sea, it's the same area. Species don't mind if what's the country that they are approaching to, and yeah, those are the main data gaps in my biology.
Mm-hmm. Yeah, thanks, Salvador. Anybody else see any gaps?
If I may complement, I mean, this is a very good answer, but I mean, there are many types of data gaps. There are observing gaps where the areas are not covered by observations. And there are also some problems with the data management. There are places where there are observations, but the data for some reason is not open, is not accessible. So these are also some data gaps that some initiatives like EMODnet are trying to fill. I mean, to get this data and make them in a standard formats with the right metadata to be openly accessed by the full community. Yeah.
All right. Anybody like to add to that?
I think I responded in there agreeing broadly that there's a lot of gaps globally, particularly in situ data, particularly in the Southern Hemisphere and things like that. But I also made a point that there's some gaps in terms of what we've been able to offer from satellites historically. And this is something that's being addressed by upcoming missions. So it's worth checking those out if you're interested in the future of remote sensing. Particular focus on doing things like addressing the coastal zones, the polar regions as well. And we've got a whole plan going forward with next generation sort of missions to increase the resolution and sensitivity and things of our missions so that we can get even more out of what we have at the moment.
Okay, thanks very much. Then I'll go on to...
If I could possibly contribute one more final point as a major gap that I'd see has kind of slightly been addressed is historically from a space-based perspective, most ocean analysis or most ocean variable retrieval was research, and now it's not. Now it's moved into the operational space, which means we should start to have more faith in providing the same service tomorrow as we do today, and hopefully providing the same service next decade as we do this decade, which means we start to move to the climate angle of things, baselining, looking at long-term changes. Historically, this has been a major gap, certainly from space.
Yeah, it is exciting times right now. Before we move on, anything else the group would like to add to that question? Okay, I've got a new view on my computer, so I'm going to try. Oh, wow, I can highlight a question. All right, so easy question. Will there be access to the slides? Yes, there will. The slides will be made available. You'll be able to download them this afternoon from the website. Ooh, okay. Very interesting presentation. How do the waves service and Storm Freddy interact at the boundary layer of the storm? Now, I see my last name tagged there, but that's way above my pay grade. Does anybody have insights into boundary layer interactions with the storm and the waves?
So I did respond to this question, but I commit to the person who posted it. I did so in a somewhat circuitous way, in that I can't definitively answer this. It is a very interesting question. And the atmospheric pressure loading is something we take into account in waveform retrieval for altimetry, significant wave height analysis, and the waveform analysis in general. I've never specifically looked at this, and it would be challenging to do so because things like large water vapor concentrations in the atmosphere do tend to tinker or become quite difficult to accommodate when doing the retrievals of significant wave height or sea surface height or any parameter around storms. Worth looking at, but I don't have a categorical answer as to how that would play out. That sounds like a research topic I should go away and investigate. I can't give you anything authoritative.
Back when I was working at DW at the German Weather Service, it might have even been a whole research project. It sounds like a very interesting thing to look into for sure. Okay, so for the group, to what extent do citizen science initiatives broaden the data collection?
May I answer first that question? And the answer is very much. I mean, it's citizen science initiatives are growing in Europe and for in situ data, and EMODnet is looking more and more to data from citizen science initiatives, since from vessels of opportunity or tourism or a lot of different science initiatives. So they are helping to broaden and to fill some data gaps that are in some geographical areas where there are no platforms there, but citizen science can fill that gap. So yeah, it's increasingly more and more filling the gap of data collection in some areas, the citizen science.
Can I add to what Vicente has very nicely said? Okay, so we have already several experiences with adding low-cost sea-level sensors, citizen science, to tide gauges and satellite altimetry. And the value is enormous. We haven't tried with Mini that in coastal areas where we have marshes with a few millimeter water, that is considered by these citizen science sensors and not by others, we can finally calibrate our models that now have marshes in it to really be able to understand their capacity, their capabilities. That's the first answer. The second one is that citizen science might be also an avenue, but that I have only seen a presentation for the new altimetry, SWOT altimetry, that would in principle be capable of getting water, with on a coastal area with a larger coverage, but that hasn't been tried. So for citizen science sea level sensors, we have already 4 or 5 prototypes. Another one I want to mention, because also a very important experience in Australia, is fishery citizen science sensor, where we use a ship of opportunities such as fisheries boats to have a sensor for temperature, at least. Now there is also salinity on a certain kind of fishing vessels. Now that contribution is already outstanding with respect on the shelf, with respect to traditional measurements such as gliders and other customary transects kind of monitoring. So citizen science is going to revolutionize the coastal resilience capacity in terms of, especially if it is well coordinated with a satellite. Conclude.
Very comprehensive and useful answer, Nadia. Before we move on, I'd like to just say that we're over time. So anybody who needs to go, you're welcome to leave the session now. No hard feelings. If you're able to stay on and process questions, then we're very happy to have you. But I know everybody has busy schedules. And for those of you in the audience, if you need to go as well, be aware that we will publish the full recording of this session. Again, you'll be able to find it on our YouTube channel and at the website, and all of the resources that we've been discussing here will also be posted there. So thank you very much for attending. And if you are needing to leave now, then wish you a good afternoon or evening. I'll just check in with the panelists if you're okay to stay on for a few more minutes to go through the last questions. Okay, great. So those of you leaving, thank you very much for the attention and for the engaging. It's been great seeing your questions, and we'll look forward to working with you in the near future for the rest of these webinars. Now we're just going to finish the rest of the questions. So the next one is for Marine, asking about the name of the software for measuring and monitoring marine heat waves.
Yes. So I wasn't sure which software this question was referring to, but I've linked in the answers to the product that I showed during the presentation, as well as the case study that was kind of linked to this topic. So the answer is on Slido, and I also saw that someone added a link to some notebooks from EUMETSAT that are related to marine heat waves. So I hope this answers the question.
Thanks very much. Yeah, super useful. Check out those notebooks. And a question for Ergan. Does the direction of the surface wind relative to the shoreline affect the degree of upwelling? That's a good question.
Yes, so yes, indeed, the direction of the wind has impact on the intensity of the upwelling. The more parallel the wind is to the coast, the more intense the upwelling will be. This is due to the Coriolis effect and the Ekman transport. So have a look at this if you're interested in understanding the upwellings.
Thanks very much. Okay, next one is directed to Ben. Ben, can we have all the data now, please?
Yeah, no problem. No, it's a good question and a relevant one, especially given the size of a lot of the data that we serve. I believe the answer that I posted is there's no hard limit on the amount that you can request per day, or even on the size of the request for data you make. You may run into some issues if you request multiple parallel downloads, in which case we would probably throttle you in line with the fair use policy. But otherwise, no, you can make very, very large data requests. It will just depend on the speed at which we can serve it to you. That's the limiting factor.
And the more data our services are putting out, the more we see that they're in use. So that's always a positive sign from our perspective. Okay, yeah, a question about internships at Copernicus. And I see there's already an answer directing the questioner towards the Mercator Ocean job opportunities page. Just to be aware, there's a number of organizations that have been presenting here. For example, EUMETSAT has its own vacancies page as well. We don't have very many internships, but if you're interested, you're welcome to follow that page, and things do pop up. So CMIMS has its job opportunities page. Any other good places to look that you guys would like to point out to attendees?
For the Copernicus Marine Service, all the openings will be posted on the page, on the Mercator Ocean page that I linked. So yeah, I think best to have a look on here.
Great, thanks, Maureen. And the next one from Nidhi. Nidhi, this is a fairly specific question. So my answer would be similar to what we were saying to the previous one. Have a look at what job opportunities are posted, and if you see something that looks like it matches what you can offer and what you're interested to do, then I'd encourage you to apply. Then next question is, are there any notebooks or data sets that can help you understand marine resource genomics better? That's one I'd also pose to the group at large.
Maybe this question can go to Salvador from EMODnet Biology. But I'm not sure if there are some notebook for that specific resource. Salvador?
No, yeah, not that I know immediately, to be honest, no. But I know OBIS has been working for a while now with marine genomics, and I think they have published some datasets now. So I think there are some resources. Yeah, if you go to OBIS, the OBIS website, or you refer to them. If not, you can always write to EMODnet, and we will check what is available at the moment.
Okay, and the next question is also focused on work opportunities, internship opportunities. Rather than repeat ourselves here, I would just encourage you to check the websites, look at vacancies, and if there's something that matches what you're looking for, reach out, apply. We'd be happy to hear from you. Then, how is AI being used to understand the communications of killer whales?
Is it? Because that'd be really cool. I don't know anything about this, but if it is, that's very cool. I'm sure it is. It's being used for everything.
Netflix. Yeah.
I'm very much more comfortable with it being applied to killer whale communications than human communications.
Yeah, I found AI often quite obfuscating in human communications, but okay, maybe that's a fluency issue. Yeah, I don't think that we have an expert on killer whale communications, but I'd encourage you to, if you're interested, clearly you're interested in these things, so great, check the internet, see what you can find, look at killer whale research, and it sounds like there might be interesting opportunities there. I do happen to know that there are several hydrophone stations that are used for whale identification, and so those would be potential sources of data because whales have identifying songs. But that's outside of the scope of my work. It's just stuff I've encountered out of my own interest. Okay, next question. How can the resolution gap between in situ observations and satellite imagery be solved, considering also the trade-off with temporal resolution? In my hubris, I might push this towards the modeling community. Yeah, any person?
Give a partial answer.
Yeah, well, please, Nadia. Yeah.
Yeah, the temporal resolution, I think, is the most important point. At this time, we have maximum coverage for, this is in general satellite imagery, so it's not talking about specific data set, but we have repeat times that are can be only twice a day. So nothing of daily timescales, like such as storms that evolve within one day, and so can be really mapped. And the only way to do that I have heard, and it's very innovative, is to use balloons, to use low airplanes, and to use lower orbit, still what is called, what is the HAPS, lower altitude pseudo satellites, as well as drones. This is clearly all very expensive. So in the time that these new technologies will come to fill the gap, in time, I would say, more than in space. Space is already considered, but in time not. Our strategy for a certain group of people is to use in situ low-cost sensor to augment incredibly the number of data with lower quality, but and use AI to learn and extrapolate in time within after having learned from a specific data set. So AI can help. Naturally, that's not so easy. You have to find a specific data set that would have some properties to have machine learning capable of extrapolating. Machine learning is good in extrapolating as well as doing forecast, because I just want to announce, if it hasn't been announced, that many of us believe that forecasting is already an AI business, more than a numerical modeling business.
Mm-hmm. Yes, it's a very exciting field to be watching right now that's developing quite rapidly. So lots of questions about what can models do, how can AI help us to fill in gaps, how many observations do we need and what type. I think we'll be learning a lot about these things as we move forward. I'll move on to the last questions. So Nidhi, what is the interview process like? Nidhi, this is dependent on the specific job that you're going for and the organization that you're working with. As you can see at the bottom of the screen, we're a number of different organizations, so we don't all have the same hiring procedures. And I'd advise you go check out the vacancy web pages and just see what you can find there. Each organization has different procedures. Is there a tutorial for learning Python and Jupyter notebooks for first-time users? Yes, there are tons in the internet. I would just Google them, frankly. I see, Ben, you're smiling. Are you smiling because you have a favorite one that you'd like to recommend, or?
Not at all. I'm smiling because at some point we had this idea that we would make our own, and then we realized there were thousands available already, so why? Yeah. So if you're wanting to learn Python, you want to learn Jupyter, there's lots and lots of resources out there. Just take a look in the internet, and I'm sure you'll find stuff. And then the last question that's open right now is also from Nidhi, asking about job eligibility. And again, because it's not the focus of this webinar, I see that somebody's already answered there, so hopefully that's helpful for you, Nidhi. And otherwise, reach out to the organization specifically that you're interested in. Okay. That takes us through all the questions. I'll count down from 3, and if somebody doesn't submit another question,
then we will close the session. 3, 2, 1. Wonderful. So thanks everybody for participating. My big thanks to the presenters and the people behind the scenes running this webinar, which has been a lot of magic. It's gone very smoothly, and it's gone smoothly because you took care of us so well. So thank you for that. And thank you to all of you who are listening in. I hope that this has been useful for you and informative, as well as inspiring, and that it helps you to find ways to address these decade-old challenges and help the oceans and help us live together with the oceans better in the future. Thanks very much, everyone. Wish you a wonderful evening.